The final unit we're going to take a look at for this year is going to be inequalities. We've done inequalities a little bit ago, but there's more to it. There's more algebra that gets infused with it. So what I want to do is take a look back at what the basics are. What is it that we're graphing, we're showing, and we'll get into solving. You have to remember back that inequalities means not equal. Okay? So I'm going to start dealing with things greater than, less than. So if you look at my first example, it says m is greater than 4. What this problem is asking is name something that is greater than 4. If I can replace m with anything, what can I put there? What can go greater than 4? 5, 6, 4.1, 2,975,337,002 is bigger than 4. Think about all the numbers bigger than 4. It's an infinite amount. It can go on and on and on. You will never finish writing out all the numbers bigger than 4. Because of this, we put a variable here. What number is bigger than 4? So what we do is we show a picture on a number line. Take the number, mark it off on the number line. Somewhere on the number line is a 4. Mark it, put a 4 there. I want all the things bigger than. Greater is to the right, so I shade in the entire right-hand side. Put an arrow with it so it continues forever. Now remember, I'm not allowed to be equal to 4, so I shade in as close as I can. Shade, 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 shade. You'll never get as close as you can to 4 without touching it. How do we show that we're trying to do this? We put a circle around it, an open circle. It goes around the mark at 4, shade to the right. Next, all the numbers less than 4. Take your number, mark it on the number line, open circle because I can't touch 4. I'm not allowed to equal 4. Open circle, shade to the left. Put an arrow with my shading. So what does this mean? Here are all the numbers bigger than 4. Pick one. I pick 20. Is 20, the number I picked, is it true that 20 is greater than 4? Yes, it is. Okay, that means I shaded the correct side. All of this shading is the solutions or answers to my problem. So m is greater than 4. Next up is, what if it's greater than or equal to? Mark off 4. Greater than, shade to the right. Equal to means I'm allowed to also shade in the number 4. How do I do it? I put a circle around 4. I shade in the circle, and I shade everything to the right. This is the picture. M is greater than or equal to 4. What's the reverse? M is less than or equal to 4. Put a mark at 4, shade in the circle, shade the number line to the left. Everything in the shading counts as an answer or a solution for my inequality. So again, you have to remember the types of circles. You have to remember the principle for what I'm doing. I'm trying to find all the numbers that make this true. Easy way to remember it, no equal sign, open circle. If there is an equal sign, closed circle. So the equal sign underneath determines if it's open or closed circle at the number. Again, this is the basics. I want to mention one more piece as far as the review goes. Shade to the right, shade to the left. Shade to the right, closed circle, shade to the left, closed circle. When you do these a bunch, you'll start picking up the pattern. Oh, my arrow points to the right. That means my shading goes to the right. Points left, shade left. Point right, shade right. Point left, shade left. But the only reason this works, right, right, left, left, right, right, left, left, is because the variable came first. The variable must be first. That's the only way you can graph based on the direction of the arrow. What happens if the arrow is not, what happens if the variable is not first? For example, -5 less than W. Well, which way does my shading go? My shading does not go left because as I read this, the variable did not come first. What you can do is you can flip it. You can flip it so the variable comes first. W would go first, -5 would go second. But if you remember from before, if I flip the number in the variable, what else has to flip? Hopefully you say, yes, it is the arrow. This inequality is exactly equal to this inequality. So keep that in mind if you are going to just shade the direction the arrow points. You must flip it so the variable always comes. Now we're going to take that idea of drawing all the solutions out and we're going to work to solve. If somebody asked me, Mr. Long, give me all the numbers greater than 8. Simple enough. I would draw a number line, I would put in 8, open circle, and I would shade to the right. I'm done, that's my answer. What's going to happen is this, you're going to start seeing inequalities that aren't just a variable by itself. What you'll have is inequalities that look like this. Say, oh, okay, what number but +7 is bigger than 8? So there's more to think about. Luckily, we know how to solve for variables, which means get the variable by itself. Okay, here's an addition equation. Why? Because there's addition. How do I get m all by itself? Add opposites. Get m by itself, get rid of an added 7. Add -7. Add -7. It still works like an equation, but it's an inequality. 7 plus -7 cancels out. I'm left with m is greater than. Now my number changes. 8 plus -7 is 1. So, in order to make this true, 7 plus a number is bigger than 8. What's the missing number? You have to solve. So your actual graph is going to be everything bigger than 1. So I would mark off 1. All the things bigger than 1. Let's take a look at one more. n minus 12 is less than 14. What number, oh by the way, take away 12, still is going to be less than 14? That's fine, let's solve for m. Anything that you have subtraction in, always turn to addition, plus -12. How do I get m by itself? Add opposites. Add opposites. What's the opposite of -12? 12. Add it to both sides. 12 plus -12 is 0, so I'm left with m. My arrow is here. 14 plus 12 now is 26. So how do I answer this question? Oh, graph everything less than 26. Draw a number line, 26, put a circle around it, open circle because it's less than, and I shade to the left. For inequalities, we can add opposites to both sides. That gets rid of added numbers. There is one special rule that's going to happen here. Here is the rule. I will flip the direction of my arrow when I multiply both sides by a negative number. I will show you how to work this rule. (3m) is greater than or equal to 12. This is the inequality I want to know all the solutions for. What numbers can go in here that when I times by 3, it's still bigger than or equal to 12? Well, there's a lot, so we're going to draw a picture. I'm going to solve for m. This is a multiplied 3. How do I get rid of a multiplied number? Multiplied by the reciprocal. What is the reciprocal of 3? Well, 3 is 3 over 1. The reciprocal is 1 over 3. 1 over 3 times 3 over 1 is 1. I'm left with n. 12 times 1/3 is the number 4. Here's the question you have to ask. It is multiplied. So, do I flip the direction of my arrow? Instead of pointing that way, do I flip it so it points this way? And no, I'm not doing some dance. Well, did I multiply by a negative number? Look, is this negative? It's not, so I don't flip it. Arrow points to the right, answer points to the right. Answer, n greater than equal to negative 4. Sorry, positive 4. There's 4, closed circle, shade to the right. Let's take a look at the second one. Negative 2/3. Let's do this. M over negative 3 is less than or equal to 6. Solve. Multiply by reciprocals. I need to get rid of the negative 3 in the bottom. Well, where do I put the reciprocal of this if I want to get rid of it? It has to be up top. Negative 3 is on the bottom, so I must put the negative 3 up top. Negative 3 as a fraction is negative 3 over 1. If I do it to one side, I have to do it to the other. Negative 3 over 1 times 1 over negative 3. The 3's cancel. I'm left with m. On this side, 6 times negative 3 is negative 18. I multiplied. Ask yourself, did I multiply both sides by a negative number? In this case, the answer is yes. Look at what I multiply both sides by. If it's negative, it tells me to flip the arrow. I'll go through why it works that way in a separate video. So my answer is all the numbers greater than or equal to negative 18. Here's negative 18, closed circle, shade to the right. So this is a look at one final example. This is a two-operation inequality. There's two operations. First, I always want to get rid of the add and subtract. 2, I'm going to get rid of the multiply and divide. The add and subtract we'll do with opposites. The multiply and divide we'll do with reciprocals. First of all, turn all subtraction to addition. This becomes plus negative 8. I want to get rid of added numbers first. Well, this is the multiplied number because it's got a times. This is my added number. How do I get rid of a negative 8? Add its opposite. Add 8. Add 8. 8 plus negative 8 is 0. I'm left with negative 2m. 3 plus 8 is 11. Now I got to ask myself, do I flip my arrow? Let's check my rule. Flip arrow when you multiply both sides by a negative number. Did I multiply? No. So this stays the same. My arrow does not flip. Next up, took care of add, subtract. Next up is multiply, divide. What is the reciprocal of negative 2? Negative 1 over 2. Negative 1 over 2. Negative 1/2 times negative 2 is 1. I'm left with m. On this half, negative half times 11 is negative 5.5. Did I multiply both sides by a negative number? I did. Negative, negative. What's that do to my arrow? Flips it. Show me all the numbers greater than negative 5.5. Negative 5.5, open circle, shade to the right. That's solving. Solving happens the same way. The only difference is the introduction of this rule. If you multiply both sides by a negative number, you must flip the direction of the arrow. Good luck.